Welcome to section 3.2, derivatives of exponential and logarithmic functions. Our goal today is to find the first derivative of functions that are exponential or logarithmic in nature. We're going to look at the definition of derivatives of exponential and logarithmic functions first. So, the derivatives we'll be using are the derivative of e to the x is itself e to the x. The derivative of b raised to an x, so any base that is greater than 0 and not 1, is going to be b to the x natural log of b. So that base is going to come back not only as itself, but in a natural log as well. The derivative of natural log of x is 1 over x, and the derivative of the log base b of x is 1 over natural log of b times 1 over x. It'll be a good idea to memorize these derivatives so that way you'll have faster calculations. Number 1, find the first derivative. F of x equals 7 e to the x plus 4x to the fifth minus 3x plus 21. So we'll start by writing f prime. We're taking the first derivative. We're taking the constant 7, derivative of e to the x, plus the constant 4, derivative of x to the fifth, minus the constant 3 times the derivative of x, plus the derivative of 21. This is going to give us 7. The derivative of e to the x is itself, e to the x. 4. The derivative of x to the fifth, we use the power rule, so 5x to the fourth. Minus 3. The derivative of x is 1. And the derivative of a constant is 0. So I'm going to clean this up. 7 e to the x plus 20x to the fourth minus 3. And that's our first derivative. F of x equals negative 5 e to the x minus 7 natural log of x minus 13x plus 4. If we take the first derivative, we'll have f prime. We'll pull the constants out front, negative 5 times the derivative of e to the x minus 7 times the derivative of natural log of x minus 13 times the derivative of x plus the derivative of 4. This will give us negative 5. The derivative of e to the x is itself, e to the x, minus 7. The derivative of natural log of x is 1 over x. The derivative, minus 13. The derivative of x is 1, and the derivative of 4 is 0. So let's clean this up. Negative 5 e to the x minus 7 over x minus 13. F of x equals 4x cubed plus 2x squared minus 5x plus natural log of x to the fifth plus e to the x. So the first thing I'm noticing here is I have an x to the fifth in my natural log. So I'm going to use log properties to rewrite that. 4x cubed plus 2x squared minus 5x plus our log properties tell us that power can come out front, natural log of x plus e to the x. Okay, let's take the derivative, f prime of x. We will have 4 times the derivative of x cubed plus 2 times the derivative of x squared minus 5 times the derivative of x plus 5 times the derivative of natural log of x plus the derivative of e to the x. So we'll have 4 times, we'll use the power rule for the derivative of x cubed, so 3x squared plus 2, another power rule, 2x minus 5, x, derivative of x is 1, plus 5, the derivative of natural log of x is 1 over x. The derivative of e to the x is itself, e to the x. Let's clean that up. 12x squared plus 4x minus 5 plus 5 over x plus e to the x. Y equals 10 to the x minus e to the third, or e cubed, minus 5x. Now, this one might fool you. It's not e to a variable. It's not e to the x. It's e cubed. That's just a number, so this is just a constant. Y prime is going to be the derivative of 10 to the x minus the derivative of e cubed minus 5 times the derivative of x. So the derivative of 10 to the x, that is 10 to the x times natural log of 10, minus the derivative of e cubed, that's a number, so the derivative of a number, the derivative of a constant is 0, minus 5, derivative of x is 1. So we've got 10 to the x, natural log of 10, minus 5. Y equals log base 7 of x plus 3x to the 5th minus 4 to the x. Y prime equals, we'll take the derivative of log base 7 of x plus 3 times the derivative of x to the 5th minus the derivative of 4 to the x. The derivative of log base 7 to the x is going to give us 1 over natural log of 7 times 1 over x. We'll have 3 times the derivative of x to the 5th, that's the power rule, 5x to the 4th, minus the derivative of 4 to the x. So we have 4 to the x, natural log 4. Okay, so we have 1 over x natural log 7 plus 15 x to the 4th minus 4 to the x natural log 4. Once you get your derivatives memorized, your basic ones, you'll really find your rhythm. Given the function f of x equals 12 e to the x plus 5, find the equation of the line tangent to the graph of the function at x equals 0. So we're looking for a tangent line. We want a line that hits this x equals 0. We're going to need a slope and an intercept, or a slope and a point, in order to do so. So let's find our first derivative, because our derivative is our equation of slopes. If f of x equals 12 e to the x plus 5, then f prime of x will be 12 times the derivative of e to the x plus the derivative of 5. This is going to give us 12. The derivative of e to the x is itself, e to the x. And the derivative of 5 is going to be 0. So now, it tells us we need to look at x equals 0. So that's what we'll do. F prime at 0. This is going to tell us the slope at 0. 12e to the 0. Anything raised to a 0 is 1, so we're just left with 12. So this is going to be our m, our slope. Now, let's find the y-coordinate that goes to this x value of 0. That way we have a point, x and y. So we'll take our equation, f of x equals 12e to the x plus 5, and we'll substitute in our x value of 0. 12e to the 0 plus 5. Now, e to the 0 is 1, so we have 12 times 1 plus 5 gives us 17. So we have x, we have m, and we have y. Let's take all of these pieces, and I have a point, x, y, and a slope, so I'm going to do point slope. Y minus y1 equals m times x minus x1. So y minus my y value of 17, my m value of 12, x minus my x value of 0. This gives us y minus 17 equals 12x. If we add 17, we'll get y equals 12x plus 17. Given the function f of x equals natural log of x to the 5th plus 2, find the equation of the line tangent to the graph of the function at x equals e. Okay, let's do it again. This time we have a more complex problem, or a more complex function. First, let's take our derivative, because that will find our slope. If f of x equals natural log of x to the 5th plus 2, then f prime of x. So we can rewrite using our log properties. This is going to be 5 natural log of x plus 2. So we'll have 5 times derivative of natural log of x plus the derivative of 2. So we've got 5 times 1 over x plus 0, so you can also write it as 5 over x. Now we want to know what is our tangent line at x equals e, so let's plug in e for x into our derivative so we know what the slope is. We have 5 over e, or we can write that as 5 e to the negative 1 using our exponent properties. Now, we have an x, we have an m, we need a y, so let's take our function, I'm going to just go with this one. And we're going to plug in e to find out what the y value is at e. Natural log e to the 5th plus 2. We know natural log and e are inverses, so this gives us 5 plus 2, which will give us 7. So we have x, y, and m, so we have a point and a slope. Let's use point slope. Y minus 7 equals 5e to the negative 1 times x minus e. And we'll have y minus 7 equals 5x e to the negative 1 minus, this one is like e to the 1, so e to the 1 and e to the negative 1 will just leave us with 5. Let's add the 7 over. Y equals 5x e to the negative 1 plus 2. And if we found out what 5 times e to the negative 1 is, we could even write it like 1.839x plus 2. And that's it for today.